Welcome to Data and AI Playground. If you're in data engineering and you feel like you're constantly learning new tools, but production system is still not stable, this video is for you. You learn Spark, you learn SQL, and then you learn some new cloud service. Then another orchestration tool comes in, but somehow pipelines still break, numbers still go wrong, and last minute fire drill still happens. That's not a tool problem, that's a pure skill problem. As a data tech leader who worked on multiple data platforms for 2 decades, both in India and UK, I've seen teams with the best tech stack struggle, and I've seen teams with a very average tools run a very stable systems. The difference was never the tech, it was the thinking. Before we talk about tools, cloud services, or frameworks, there are four non negotiable skills in data engineering. If these are missing, no tech stack can save you. Once these are in place, learning any tech stack becomes much easier. So we'll start with these four first, and then I'll talk about the tech stack. The first non negotiable skill is system thinking. System thinking is not about fixing issues after something breaks, it's about designing data systems so they behave correctly in the real world. As data engineers, it's very easy to think only in terms of task. We say, I just need to transform this table and load it. But that's only one piece of much larger system. Data always has a context. Something produces it or generates it, something else consumes it. And in between, there are expectations about freshness, accuracy, and reliability. Now, think about designing a daily reporting pipeline. You already know that sources can be late, schemas will evolve over time, and downstream teams are depending on this data every morning to make decisions. Systems thinking forces you to decide these things upfront. Should this pipeline wait if data is late, or should it fail? Is partial data acceptable or should everything be blocked? What freshness guarantees are we actually committing to? These are not coding questions, they are architecture and design decisions. When you start thinking this way, you stop building pipelines that only work in ideal conditions. You start building data systems that reflect how the business actually operates. That's what system thinking really means in data engineering. The second non-negotiable skill is problem solving and debugging. And debugging data system is very different from debugging application code. In applications, something usually crashes and you know exactly where to look. In data system, everything can succeed and still be wrong. That's what makes it tricky. I've seen situations where dashboards look perfectly fine for weeks, then suddenly business numbers drop. No pipeline failures, no alerts, no recent deployment. From outside, nothing seemed to have changed. When this happens, strong data engineers don't panic. They don't immediately start changing code or rerunning the jobs. They slow down and they start narrowing the problem. They ask basic but very powerful questions. Is this a data issue or the logic issue? Did this start today or has it been happening silently for some time back? Is it affecting all the records or only a very specific subset? They isolate the issue step by step instead of guessing. In one real case, the root cause turned out to be a source system changing how null values were populated. There was no code change on our side, but the meaning of the data has changed. This kind of structured thinking saves days of trials and error. And during incidents, the person who stays calm and narrows the problem fastest becomes the go to person. System thinking defines how data should behave, whereas debugging explains why it didn't. The third non negotiable skill is delivery. Data work almost always looks simple on Jira. You will see a task like add a new column, deliver this metric, but once you start working on it, you realize the data exposes all the messiness of the business. Definitions don't always match across the teams. Historical data behaves differently than expected. Edge cases comes up that were never discussed before because nobody thought about them earlier. At that point, the task becomes just being technical, it becomes more exploratory work. This is where estimations become tricky. You're not just estimating how long it takes to write a code, you're estimating how long it takes to understand the problem properly. Experienced engineers recognize this yearly. They don't commit to timelines just because the ticket looks so small. They will say something like, let's first validate the assumptions and data behavior and then commit to a date. This approach also helps with handling a change. Because change is not an exception in data system, it's the default one. Where schemas can evolve over time, business logics can change, and new use cases keep appearing. Good data systems are designed with this in mind. They expect change and absorb it. Bad systems work fine until the first meaningful change arrives, and that's when things start breaking. When you handle delivery this way, by acknowledging uncertainty, planning the exploration, and designing for change, estimates become more realistic. Expectations are clear, and delivery becomes predictable, even in a constantly changing environment. The fourth non negotiable skill is communication and ownership. And this one skill people usually underestimate because communication is not about talking more or giving long explanations. It's about saying the right thing to the right people at the right time. This becomes very clear during incidents. Something looks off in production, dashboards don't match the expectations, Slack or team messages start coming in. Business teams are anxious. At that moment, they're not looking for a big root cause analysis. They're asking very practical questions. Can we trust today's data? Should decisions be paused? When will this be stable again? A common mistake engineers make is in responding with technical details. A pipeline failed, a data factory issue, schema mismatch. All that information might be correct, but it doesn't answer what the business actually cares about. Experienced data engineers communicate differently. They translate technical problems into business impact. Instead of saying the job failed, they say today's sales dashboard will be delayed by 2 hours. That one sentence reduces panic immediately. Ownership doesn't stop when the issue is fixed, it continues after. Explaining what happened in simple terms, adding safeguards, improving validation or monitoring so that the same issue doesn't repeat. Over time, people may not remember the exact technical fix, but they remember who stayed calm, they remember who communicated clearly, they remember who followed through. That's how the trust is built in data teams. So once these 4 non-negotiable skills are in place, system thinking, debugging, delivery and communication, tools finally start to matter. Without these skills, tools are just buttons you click. With these skills, tools become leverage. Now let's talk about the Microsoft data stack through that lens. We'll cover the top 6 areas: SQL and programming, the foundation. Everything in data engineering still starts with SQL. On the Microsoft stack, that usually means working with SQL Server, Azure SQL, Synapse, or Fabric warehouses. This is where data modeling happens. This is where joins, aggregation, and business logic live. If your SQL fundamentals are weak, everything else feels unnecessarily complex. Along with SQL, you need at least one programming language, usually Python or Spark, not for fancy code, but for handling messy data, edge cases, automation, and custom logic that SQL alone cannot handle. Next comes orchestration, which is about control. What runs first, what depends on what happens when something fails at 3 a.m. On Microsoft's side, this usually means Azure Data Factory and Fabric data pipelines. These tools help you manage workflows, retries, dependencies, backfills, and failure boundaries. Good orchestration is what turns scripts into reliable systems. Next comes big data processing. As the data grows, simple SQL is not always enough. That's where distributed processing comes in. In the Microsoft ecosystem, this usually means Azure Databricks, Synapse, or Fabric Spark. But this is important to remember. Spark doesn't fix bad data, it only processes bad data faster. Without good upstream design and validation, scale just amplifies the problems. Next is storage and data modeling. Understanding where data lives is critical. On Azure, this usually means Azure Data Lake Storage Gen 2, Delta Lake, or Fabric One Lake. Your storage and modeling choices directly affect performance, cost, and reliability. Good models make system predictable and poor models make even simple queries painful. Next comes Git and version control. Azure DevOps, Git, or GitHub, the tool doesn't matter. What matters is versioning everything. Pipelines, notebooks, SQL scripts, and configuration. When something breaks, you don't guess. You know exactly what changed. And final one is CI/CD, which is continuous integration and continuous deployment to ensure safe delivery across environments. CI/CD is what allows teams to move fast without breaking things. On Microsoft Stack, this usually means Azure DevOps pipeline or GitHub Actions. Promoting changes safely from dev to test to production drastically reduces incident. It also makes rollbacks and hotfixes much safer. So yes, tools matter, but only after these 4 non-negotiable skills are in place: system thinking, problem solving under pressure, delivery in the face of constant change, and communication with ownership. Once you build these, the Microsoft stack or any tech stack becomes learnable. That's how you stay relevant in data engineering. In the next video, I will break this Microsoft stack down step by step. Thanks again for watching Data and AI Playground.